heat capacity. See, this term is introduced in this thermodynamics in order to find out that how much of heat has been transferred to a system, how we can find out, or how it is expressed. It is expressed in terms of this term, heat capacity, which is given a symbol C. See, we have basically two more related terms which are called specific heat capacity and molar heat capacity. Now let me describe you the heat capacity. It is the amount of energy required to raise the temperature of a substance by 1 degree Celsius. So energy required to raise temperature by 1 degree Celsius or 1 Kelvin of any substance is called its heat capacity. But how much of substance is taken, that's not defined. So when this is the amount of substance taken is taken as 1 gram, remember it's called specific heat capacity. So it is the, what is specific heat capacity is the energy required to raise temperature of, it is energy required to raise the temperature of 1 gram of substance by 1 degree Celsius or 1 Kelvin. So when it is 1 gram, it's specific heat capacity. But normally we use this, or we take the amount of the substance in terms of its moles. That's why we have the third term called molar heat capacity. Molar heat capacity is, it's the amount of heat required to raise the temperature of 1 mole of substance by 1 degree Celsius or 1 Kelvin. And we have therefore this molar heat capacity of two types, Cp and Cv. What's the difference? This is molar heat capacity at constant pressure, and this is at constant volume. So this is what is basically we have heat capacity. Now we need to know that suppose we know that whenever we are giving heat to any system, its temperature gets increased, and if we are giving that heat at constant volume, we write it QV, and if we are giving this heat at constant pressure, we call it QP. Now we need to know this. What is most important is that if we know the Cv, that means Cv of that substance, that means how much of heat is required to raise the temperature of a given amount, the 1 mole of a substance by 1 degree Celsius, how much of temperature, how much degrees or how much Celsius of the temperature has been increased. If we multiply that by delta T, what we can get is QV. So that's most interesting, and we know that this is equal to delta U. Whereas QP is Cp into delta T, that how much of the temperature has increased. Suppose that the substance, 1 mole of the substance was at 25 degrees Celsius, on heating its temperature is increased to 50. So since 25 degrees Celsius of temperature has been increased, so we will multiply the Cp by 25, because we know this much of heat is required to raise the temperature by 1 degree Celsius. So to increase it by 25, we'll multiply it by 25. So this is what we have is, and this is, we know that is called delta H naught. So this is the very important relationship we are having, and from here what we can make out is that we know delta H naught is equal to delta U plus delta of PV. We can write delta naught is equal to delta U plus, we can write delta RT, because this is for 1 mole of gas, because PV is equal to RT and is taken as 1. What we can do is we can take out this R out of this. Delta H naught is equal to delta U plus R delta T. If we divide both the sides by delta T, what we get is like let's do like this, delta T by delta T by delta T. So what we get is this gets cancelled. This we know is yours. If we bring this delta T here, what we get is this is Cp is equal to Cv plus R. From here we get the Cp and the Cv. So it becomes what? Cp minus Cv is equal to R. You will be doing these relationships more in detail in your physics because they are more important there. There we have the Poisson's constant also uses that, which gives us the atomicity of a gas, how the atomicity also makes difference in the Cp, Cv values. But here we are not going into the too much of details of here about this heat capacities. We only have to get an idea that how much heat is being transferred. Yes, we can find out from these formulas.